Today you are going to learn a new topic called as formation of differential equation. So how differential equations are being formed. So for that let us consider one example. Say y is equals to ax plus a square. So we'll be differentiating this above equation with respect to x. So we'll get a solution like this: dy by dx is equals to a. Let me mark this as equation number 1. Putting this value in this, so we'll get as y is equals to dy by dx into x plus dy by dx the whole square. So thus by eliminating equation 1, in place of a, so we get a differential equation which is of order 1. So I'll give you two more example questions. Y is equals to a cos x plus b sin x, and y square is equals to ax square plus bx plus c. You can try out these equations and see whether you get the differential equations for these equations or not. Okay, so now I'm going to start a new topic called it as a differential equation of first order and first degree. As we know, there are different methods to solve the differential equation. So first method is, we call it as a separation of variables. Second method is homogeneous equation form. Third one is linear equation of first order. And the fourth method is exact differential equation. So I'm going to start with this first method, that is variables separable. So if you can write your differential equation of this form, f of y into dy is equals to phi of x into dx, then we say that the variables are separable. That is, your LHS will have y variables and the RHS are having x variables. But we will get our solution by integrating both the sides. So we get solution by integrating both sides. So let us write the steps for solving the variables. So let me write it as working rule. So my first step, so you say step number 1 is to separate the variables. So separate the variables as, how we have to separate it? Like this. So write it out: f of y dy is equals to phi of x dx. Next step is step number 2. Step number 2 is we have to integrate both the sides. So integrate both the sides. So it's just simply adding an integration sign. Integral fy dy is equals to integral phi of x dx. And my next step, that is step number 3, is to add arbitrary constant C that is also along the RHS. So the working rule is, first we should separate our variables. So variables should be f of y dy is equals to phi of x dx form. Then we have to integrate both the sides, and then we have to add the constant variable, and that too is along the RHS only. So we'll solve one example. So I'll name it as example 1. So dy by dx is equals to x 2 log x plus 1 divided by sin y plus y cos y. So solution. So my step 1 is separate the variables. So separating the variables, what I'll do, I'll take all these y terms towards this side, and this dx I'll take towards this side. So my LHS will have y term and my RHS will have the x term. So separate the variables, we get, that is sin y plus y cos y bracket dy is equals to x bracket 2 log x plus 1 close the bracket dx. My step 2 will be integrating both the sides, and step 3 also I'll add it here only. So step 2 and 3, so integrate both the sides and add c. So integral open bracket sin y plus y cos y dy is equals to integral, then curly bracket x 2 log x plus 1 close the bracket, close this curly bracket dx plus c. So I have mixed step 2 and step 3 together. Okay, so now integration of this term, I'll get minus cos y plus y sin y, and then this term again minus integral y, that is 1, and then sin y dy. This is my LHS term. Now I will solve the RHS term, which is equals to, I'll write it down, that is 2 integral log x into x dx plus integral x dx plus c. Okay, now I'll solve these three integrals. Now minus cos y plus y sin y, integral sin y dy, I will get it as cos y, that is minus cos y. So this minus and that this minus will become plus, so it will be plus cos y which is equals to, I'll write it down here, 2 in bracket log x into x square by 2 minus again integral 1 by x into x square by 2 into dx, close the bracket, plus integral x dx, you are getting it as x square by 2 plus c. Now this term and this term goes away, so we are getting it as y sin y, which is equals to, now see this terms, you are getting something like this, 2 log x into x square by 2, this term, okay, I'm opening the bracket, minus x square by 2 and plus x square by 2 plus c. Now in this term and this term goes away, so we are getting something as y sin y, and which is equals to x square log x plus c. So thus this is our solution by using the method of separable of variables. So I'll just give you two more example questions. X raised to 4 dy by dx plus x cube y is equals to minus secant of xy, and one more, cos x plus y dy is equals to dx. So in this lecture we have learned the formation of variables, formation of differential equation, then the differential equation of first order and first degree, and their different types. We have started with the variable separable. We have learned the working steps, that is step 1, 2, 3, and we have done one examples also. So thanks for watching.